Hi everyone, I'm Dr. Media. Listen, today our topic is electronegativity. So let's start. What is electronegativity? Electronegativity is basically is the measure of the ability of an atom in a bond to attract the electrons, and which bond would have a greater attraction for the electrons in this bond and why. So let's see while Pauling experiment and Louis Pauling, basically American chemist and winner of two Nobel Prizes, came up with the concept of electronegativity, I think 1932, to help to explain the nature of the chemical bonds. So let's see. Electronegativity is of the some elements based on the bond dissociation energies, and seven group element. Fluorine has four according to Pauling scale, and cesium has zero point 0.7, which belongs to a first element group, alkali metal, last member. Now, electronegativity is looking across a row or down a group of the periodic table. We can see a trend in the values, and what it can be possible that what are the electronegativities of these elements across the periodic table. Just like lithium has the one, oxygen 3.5, nitrogen 3, carbon 2.5, and boron 2. And similarly, looking down, what are the electronegativities of these halogens? First member is fluorine. It has electronegativity of 4, and iodine has 2.6. It's going down less. Millikan scales propose the electronegativity scales in which the Millikan electronegativity is xm is related to the electron affinity and the atom to form a negative species and ionization potential ionization energy measured to tendency in atom to form a positive species and ionic sizes which also depend. Millikan element easily lose electrons and non-metal more readily gain electrons. So, how does losing or gaining an electron affects the size of the atom or maybe ion? So, positive ions are always smaller than the neutral atom and loss of the outer shell of electrons. Negative ions are always larger than the neutral atom, gaining the electron. And what is the ionic or covalent bond? You can say that both these bonds, salt, ionic concept, salt crystals, repeating patterns of the positive ions, cations, and anions, which held together to form electrostatic attraction, just like sodium chloride, common salt, and similarly covalent compound biological molecules which are covalently bonded most of consist of non-metals, just like carbon, oxygen, and hydrogen and nitrogen. Next one is, so ionic and covalent bond are very difficult or different, but how do we predict if a bond will be ionic or covalent? The electronegativities of an element help to understand the difference between ionic and a covalent bond. How electronegativity is basically is a measure of the ability of an atom in a bond to attract the electrons, and these basic elements with the high electronegativities have a strong pull on electrons, just like fluorine and carbon. But elements with the low electronegativities have a weak pull on electrons, and these strength, when two atoms form a bond, the difference in the electronegativity determine the bond type. Large difference in electronegativity means one atom will win the tug of war and take the electrons completely. This is an ionic bond. And when the electronegativity of the two bonding atom is very similar, the atom wins the tug of the war and the electrons are shared equally. This basically is a covalent bond. In a true covalent bond, electrons are shared equally, and you can imagine that what is the difference between ionic and covalent bond. Difference: transfer electrons between an atom of an high electronegativity and atom of a low electronegativity, examples like sodium chloride, and covalent between two atoms of equal or very close electronegativities, just like nitrogen. So that was the basic concept of electronegativities. Comparison of ionic polar and a non-polar bond. We can say that ions, complete transfer of electrons, full ionic charges. Similarly, polar and non-polar unequal sharing of electrons, and polar equal sharing, and ionic complete transfer of the electrons. Examples are sodium chloride, hydrogen chloride, and similarly is two identical nonmetals which has no charges. Compare the non-polar bond. That's it. Thank you.